So now we'll discuss about two-dimensional arrays. Okay. So the concept of two-dimensional arrays will be helpful in order to store the data inside a table or matrix representation. So especially while working with data structures such as graphs, we require data to be stored inside a matrix. For example, adjacency matrix representation. So these two-dimensional arrays are very important data structures. Okay. So let's see how we can declare, okay, how we can initialize and how we can display these two-dimensional arrays. Okay, let's get started. So coming to two-dimensional arrays, okay. So in this two-dimensional arrays, first consider in order to basically store the data inside the matrix or table, so we require the information about number of rows and number of columns, isn't it? How many rows are there and how many columns are there in order to store the data inside 2D array. Okay. So now if you see the syntax of this two-dimensional array, so it can be written like this: data type. Now we can write a variable name, or this can be array name, and here we can specify the row size and followed by the column size, then semicolon. Okay. So row size is representing the number of rows inside the table or matrix, and col size is indicating the number of columns inside the table or matrix. Okay. So if you observe an example for this, you can see int a of 2 4. So now we are looking into a two-dimensional array which is of integer data type. Okay. So this is going to create a table which is of size 2 by 4. So it contains 2 rows and 4 columns. Okay, it contains 2 rows and 4 columns. 1, 2, 3, 4. Okay. So what are their corresponding memory locations here? So this is going to be 0, 1, and this is 0, 1, 2, 3. So this memory location is clearly belonging to A of 0, 0, and this is A of 0, 1. This is A of 0, 2. This is A of 0, 3. Okay. And this is A of 1, 0. A of 1, 1. This is A of 1, 2. This is A of 1, 3. Like this. So totally there are 4 plus 4, 8 elements can be stored inside this particular array. Okay. So the number of elements that can be stored inside the two-dimensional array is equal to row size into column size. Okay. So we can say number of elements that are can be stored inside the array is equal to row size into column size. Okay. So since the row size given here is 2 and column size given is 4, 2 into 4 equal to 8. So therefore number of elements that can be stored here is 8 elements, isn't it? Like this. So now let's consider an example initialization of the 2D array at compile time. Okay. So in order to initialize at compile time, you can see here clearly compile time initialization. Okay, so according to this compile time initialization, the syntax for this compile time initialization of the 2D array will be like this. Okay, so first of all, we need to consider the data type here. Data type space, okay, array name, okay, and you can see here row size and column size is equal to list of values, is equal to list of values. Clear? Just like this. So we can write the list of values to be initialized here. And again, in this list of values, we can use number of initializer lists is equal to number of rows. Or you can simply write all the elements of this 2D array one by one. Okay. So I'll show you in examples. So for example, int a of 2 3, int a of 2 3, 2 into 3 equal to 6. Okay, there are 6 memory locations here. So in these 6 memory locations, how you can initialize them is that first of all, you can take two different rows and initialize them like this: 1 2 3 in the first row, and then 4 5 6 in the second row, like this. And if you consider the other type of initialization, you can write like this: int a of 2 3 is equal to, you can actually initialize all these memory locations one by one by writing all the elements directly. Okay, like 1 2 3 4 5 6. Okay, just like this. So this is how we can initialize these elements. Okay, now how these values are getting stored inside this two-dimensional array. So you can observe here, this is clearly two-dimensional array where the elements are stored in two rows. Okay, this is row 0, row 1, and how many column elements are there? Totally 3 column elements are there: 1 2 3. Okay, so you can observe in the first row, that is 1 2 3, and in the second row 4 5 6. Okay, so these are the elements stored inside the 2D array like this. Okay, so now you can observe here clearly with an example. This is compile time initialization, and now we'll discuss about runtime initialization, how we can initialize this two-dimensional array at runtime. Okay, so let's consider this particular program. For discussing about runtime initialization, you can see first we have to declare this runtime. Okay, initialization of the array. So that is, for example, int a of 10 10, let us suppose. So this is going to allocate memory for array A in the form of a table, right? So in the table, by default, you will see here row size is 10 and column size is 10, which is 10 by 10 is equal to 100 memory locations are allocated for this particular array A. Okay. So, but out of these 100 memory locations, I want to use only few memory locations inside this particular array. Okay. So how this can be done? This can be done based on the row size and column size which are taken at runtime. Okay. So you can observe here, this is row. Okay. And you can see I'm using a variable called row and col. Okay, which for taking the values of row size and column size at runtime. and then I'm using I comma j. Okay, so I comma j are the loop variables, and using these loop variables we are going to iterate the entire array and store these elements into 2D array. Okay, so now you can see here, first of all, for you can prompt the user to enter order of the matrix. Let us suppose in the order of the matrix, obviously you will enter row size and column size, isn't it? So let's ask the user to enter order of matrix. Order of matrix. So once the user enters the order of the matrix, this information should be taken inside the array. Okay, so basically first you have to store row size and column size with the help of two variables, row and column respectively. Percentage d address of row comma address of call. Okay, clear? So now using for loop you can access the entire array and store this data inside the array. Okay, so how this can be done is that first of all we can print a message saying that enter elements into array. So how many elements can be entered inside this particular array is equal to row into column. Row size into column size will give you the number of elements to be entered inside the array. Okay, so we can write like this, enter percentage d elements into array, so which is given as row into column. Okay, so row size into column size. Now once the user starts entering those number of elements, okay, so you can observe for I is equal to 0, I less than row, I plus plus. Okay, this is using row size. Okay, next using column you can see for j equal to 0, j less than column, j plus plus. Okay, so now we can write using scanf statement, scanf percentage d. Okay, address of a of ij. Okay, a of I j, like this. You can read data into this particular matrix, address of a of ij. Okay, so once the elements are taken into this particular array, now we can display these elements in the form of a matrix. Okay, so we can display in the form of a matrix just like this. So displaying elements. So how these elements can be displayed is that first write the outer for loop to access the elements row wise, I less than row, I plus plus. Okay, so for j equal to 0, j less than column, j plus plus. Okay, and now how we can display here is that using printf statement we can display the elements of this particular 2D array as a percentage d slash t, a of ij. We can display here a of ij, and after this for loop now you can use a slash n. Okay, which is basically a new line, percent slash n here. Okay, and close the entire main function. Okay, so this is how you can access and display the elements inside a two-dimensional array. Okay, so first of all you can see here, enter the order of the matrix. Okay, so address of row comma address of column. In this case, first user is prompted to enter order of the matrix. Okay, let us suppose enter order of matrix is printed, and the user has entered order of the matrix as a 2 3. Okay, next the next statement immediately printed is enter percentage d elements, so which is row into column, that is 2 into 3 equal to 6. So enter 6 elements. Okay, so now using nested for loop, you can actually read the entire elements inside the 2D array. Okay, so let's see here, you have entered total of 2 by 3, which is equal to 6 elements, isn't it? Suppose those 6 elements are 1 2 3 4 5 6. Okay, so let's see how these 6 elements are going to be accessed and displayed here with the help of this code. Okay, so let's see here, the same array 1 2 3 4 5 6. Okay, 2 rows and there are 3 columns. Okay, 1 2 3 4 5 6, and you can see the array elements are stored is in these memory locations: a of 0 0, a of 0 1, a of 0 2. Okay, there are totally 2 rows here. Now you can see a of 1 0, a of 1 1. Okay, a of 1 2, like this. Okay, so now how you can display the output? Okay, how output can be displayed here? See here, I equal to 0. Yes, I value is 0. Now 0 less than row. Okay, so what is the row value here? Clearly row value is taken as 2. So I less than 2, which means 0 less than 2 condition true. Okay, and you can see here, I is equal to 0 right now. Okay, and j equal to 0. So 0 less than 3. Okay, column value is 3. So 0 less than 3 condition true. Now the associated value at a of ij memory location will be displayed, which is a of 0 0. Okay, so a of 0 0 will be displayed, and then there will be a tab space printed. Okay, so in the next iteration, j plus plus j value is incremented, j value will become 1. Okay, 1 less than 3 condition true, and a of 0 1, you can see this particular value will be displayed after tab space. Now in the next iteration, j plus plus j value becomes 2, 2 less than 3 condition true, and a of 0 2 will be displayed, that is 3 will be displayed. So now after this, j value becomes 3, 3 less than 3 condition becomes false, associated block of statements will not be executed, and now going to the new line. So now it will go to the next iteration, I plus plus I value becomes 1, this time 1 less than 2 condition true. So now j loop will be executed, j equal to 0, 0 less than 3 condition true. So again, after going to the new line, this particular row will be accessed and displayed one by one, similar to the previous row. 4 5 6 will be displayed. Okay, so like this is going to be a matrix representation, yes or no? It contains 2 rows, and each row has got 3 column elements. So this is how you can access entire 2D array. Okay, so next one is, we need to write code in order to display a matrix after reading it. Okay, so clearly this is related to 2-dimensional array. That is read and display matrix. Okay, so let's see how we can read and display matrix. First we need to include the header file. Okay, so after including the header file, then in the main function, first of all, let's consider a 2-dimensional array. Okay, suppose A is 2-dimensional array.
Okay, initially we are allocating 10 by 10 size. Then we'll take size of the row and column size at runtime. Okay, and in order to iterate, we will consider ij variables. Okay, so first here we will prompt the user to enter size of the matrix. Okay, enter, we can say row size and column size of matrix. So once the user enters the row size and column size, then using scanf statement, you can read row size and column size here. So %d, address of row, comma, address of call. So row size and column size must be taken. And after taking this row size and column size, now we will read this entire matrix, okay, by prompting the user to basically enter %d elements. Okay, so those number of elements are row size into column size, yes or no? So the number of elements that can be stored inside a two-dimensional array is equal to row size into column size. Okay, so using nested for loop, we can read into this particular 2D array. Okay, so you can see here for I is equal to 0, I less than row I plus plus. This is outer for loop. So similarly, you can directly write here for inner for loop, j equal to 0, j less than column j plus plus. Okay, here you can write scanf statement in order to read the element into array. %d, address of a of ij. Okay, so now let's write code to display the matrix. For displaying the matrix, you can write like this: displaying matrix form. So first outer for loop is written I equal to 0, I less than row I plus plus to iterate row wise. Okay, and then consider j loop iterating from 0 to column j plus plus. Okay, and here you can print using tab space printf %d /t. Okay, so the element is stored basically in a of ij, right? So after printing row wise, once one particular row is completed, now you can make use of /n to move to the next line and start printing the next row. So this is a complete program in order to read and display the matrix. Okay, so let me explain here. First, user is basically prompted to enter row size and column size. For example, row is equal to 2 and column is equal to 3. Okay, then it is going to create a matrix of size 2 by 3. Yes or no? So there will be 2 rows and there will be 3 columns. Okay, so 0 1 0 1 2. Okay, so you can observe here clearly. Let us suppose user has entered values like 10 20 30 40 50 60. So now using this particular loop, okay, it is going to display, yes or no? So you can clearly see here the nested for loop. So how this is going to work is that first of all, when I is equal to 0, it will work for j equal to 0 and displays the corresponding element. Okay, corresponding element is 10. So later for the same I equal to 0, j value becomes 1. Okay, and now this next element will be displayed with a tab space. Then j value becomes 2. So now the next element will be displayed with tab space, that is 30. So after execution of j loop, now j value becomes 3, but j less than call, 3 less than 3 condition becomes false. So it will go for the outer for loop and increments I value by 1. Again, for I is equal to 1, it is going to work for j equal to 0, j equal to 1 and j equal to 2. Okay, so it means for I equal to 1, okay, by the time you can see already there is a slash and new line. It will go to the new line and start printing the second row, that is 40, 50 and 60, just like this. Okay, so now next program is display transpose of a matrix. Display transpose of a matrix. Okay, so how can we display the transpose of a matrix? Clear? So for example, consider compile time initialization of the matrix. Okay, so that we'll see here focusing on transpose of the matrix. Okay, so in the main function, I'm considering an array like this. Int a of 3, 3 is equal to, now it is 1, 2, 3. Okay, 4, 5, 6, row wise initialization I'm performing here, 7, 8, 9. Okay, and then for outer for loop I'm using I, and for inner for loop I'm using j. Okay, so now we can display the entire contents of this particular matrix, okay, by writing nested for loop. Consider like this: for I equal to 0, I less than 3, I plus plus. For j equal to 0, okay, again the j loop, number of column elements in each row will be up to 3, right? So instead of displaying ij, suppose if you are writing percentage the a of ij, you will get original order of the matrix, yes or no? So original matrix you will be able to display, but all we need is a transpose of the matrix here. So in order to display the transpose of the matrix, the logic is, instead of writing a of ij, write down a of ji. A of ji. So once this printf statement is over, now we need to write printf for /n, going to the new line. Okay, so you can observe this is the for loop, okay, outer for loop, and this is the closing of the main function. Okay, so let's see this minimal code with which we can perform transpose of the matrix. Let me explain here clearly. So what is this line doing exactly? It is going to create a 3 by 3 matrix. Okay, 3 rows and 3 columns exactly. So 1, 2, 3. Okay, so 0, 1, 2, and again here also 0, 1, 2. What are the elements in the first row? The elements in the first row are 1, 2, 3. And the elements in the second row are 4, 5, 6. And the elements in the third row are 7, 8, 9. Okay. So now we need to display a of ji. Clear? So you can see for I equal to 0, first of all, while displaying the output, you can see here I equal to 0. For I equal to 0, j equal to 0. Okay, j is also 0. And you are printing a of 0, 0. So this one and this one, right? Okay. So which means 1 will be displayed. In the next iteration, j plus plus, j value becomes 1. Okay. So when j value becomes 1 and you're asking to print a of 1, 0, because a of ji means currently I is equal to 0 and j equal to 1, which is a of 1, 0. A of 1, 0 is nothing but 4. So 4 will be displayed. In the next iteration, again I is equal to 0, but j value is incremented. J value becomes 2. So this is a of ji, which is a of 2, 0. So this value will be displayed, that is 7. So in the next iteration, you can see clearly j plus plus j value becomes 3. 3 less than 3 condition becomes false, and it will go for the outer for loop. I plus plus I value becomes 1. Okay, so you can see here I equal to 0. Okay, I equal to 1, I equal to 2. So now we are going to refer here. Okay, so I value is currently 1 this time. Okay, and what is j value? J value is going to iterate from 0, 1, 2. So it means in the next row you are going to get results like this: a of 0, 1, then a of 1, 1 will be displayed, and then a of 2, 1 will be displayed in the next row. So which means this particular column, yes or no, 0, 1, 1, 1, 2, 1. So that is displayed as the row here. Similarly, when I value is incremented and I value becomes 2, again for I is equal to 2, j value will be iterating from j equal to 0, j equal to 1, j equal to 2. So again a of ji means it is going to display a of 0, 2, a of 0. Okay, you can see j value is 1, a of 1, 2, and then a of 2, 2. Clear? So you will get this particular column again. So this will be 3, 6, 9. Okay, so this is purely the transpose of the given matrix. Okay, we can print transpose of the matrix like this. Hello guys, in this video we'll see the program related to two-dimensional array in order to compute the trace of a matrix. Okay, the program is clearly to compute trace of a matrix. So what is meant by trace of a matrix? First of all, you can see, if you consider this is the matrix containing like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see trace of the matrix means basically adding of all diagonal elements in the array. Okay, so how this can be done? This is a diagonal element, this is a diagonal element, and this is also a diagonal element. Sum of the diagonal elements is nothing but trace of a matrix. So from this we can write trace is equal to 1 plus 5 plus 9, which is equal to 15. Okay, so this is how we can compute trace of a matrix. Okay, now let's see how we can compute, how we can write the code respect to this. So first we need to take header file or include the header file. So after including this header file in the main function, first of all just declare the array first of all. Suppose array A, and size of array A 10 10, let us declare, and consider row size and column size I comma j. Okay, so from this you can also write a trace of a matrix like this. Initially consider trace is equal to 0, because I'm going to add this trace of a matrix. All the diagonal elements I'm going to add it to the variable called trace. Okay, so let's first take the order of the matrix as input. Okay, so enter order of matrix. So once it enters order of the matrix, we have to read that order. Order basically contains row and column, isn't it? So percentage D, address of row comma address of column. Okay, so now we need to prompt the user to enter elements into array. So how many elements you have to enter? Enter percentage D elements. Okay. So you can see number of elements row into col. Okay, those many elements must be entered. Now using for loop, we can read those elements into the array. Okay, so this is a two-dimensional array, right? So you can see for I is equal to 0, I less than a row, I plus plus. Okay, so now again j equal to 0. J is a loop variable which is used to iterate column wise in the same row. Okay, so now using scanf statement, you can read like this: scanf percentage D address of A of ij. Okay, so once the elements are read inside this two-dimensional array, now we can perform the action, that is adding all the diagonal elements. Okay, so let me do this functionality first. I less than 0, I equal to 0, I less than row, I plus plus, and then look at the j loop. J equal to 0, j less than column, j plus plus. Now if how to identify the trace of the matrix, like how this element belongs to the diagonal element or not, how to check this? Okay, so always remember, for diagonal elements the row number and column number must be same for the diagonal elements. Okay, so simply consider like this: A11, A12, A13, similarly A21, A22, A23, A31, A32, A33. This is the entire matrix. Now in this matrix you can see these are the diagonal elements. If you observe the diagonal elements and write down the diagonal elements here: A11, A22, A33. So here row number and column number both are same. Here also row number, column number both are same. Here also row number and column number both are same. Okay, it means whenever I double equal to j, in that case we have to add this to the trace. Okay, so trace plus equal to, we need to add a of ij. Okay, so like this. Once you identify the entire trace, then you need to display this particular trace. So we can actually write a simple statement to display the trace. Okay, so I'll show you here. Just write down the printf statement and display trace of matrix. Okay, is equal to percentage d slash n. So trace, basically I have stored it in a variable called trace. Okay. And finally close this main function. Clear? So this is the entire code. So using which you can see, if you are considering a sample input like this, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 example. Okay. So you can see this particular element is stored in A of 0, 0, this particular element. This is stored in A of 0, 1. This is stored in A of 0, 2. Okay. And you can see this particular element is stored in A of 1, 0. And this element is stored in A of 1, 1. And this element is stored in A of 1, 2. And finally, this particular elements are stored in A of 2, 0, A of 2, 1, A of 2, 2. Okay. Like this. So if we add this, you can see everywhere A of 0, 0, A of 1, 1, A of 2, 2. These elements must be added. And for these elements, if you see here I double equal to j, condition true. So we are adding only those elements. Okay. So in the first I equal to 0, you are adding 1. Okay. In the next iteration of I, where j will be iterated for each and every element in the entire row, okay, you will be adding this particular element. And finally, I value becomes 2 and j value becomes 2. You will add this particular element. So trace will be printed as 15 for this particular example. Okay. So like this, we can compute the trace of the matrix. Okay. So now in this example, I'll show you execution and also the result. So given program is clearly, we need to count the number of zero and non-zero elements in the matrix. Okay. So we are considering a matrix, and in this matrix, we need to count how many zero elements are there and how many non-zero elements are there. Okay. So for this purpose, first of all, just like what I have explained previously, you take a two-dimensional array, for example, 10 by 10. Okay. So now consider I variable, j variable. Okay. So, and then also consider row, column, where you will be taking the order of the matrix into row and column. Okay. So in order to count the number of zero elements, consider z equal to 0, where I'm counting number of zero elements in a variable called z. Okay. And non-zero elements, nz equal to 0. Okay. So for this purpose, we can count just like this. First, we can ask the user or prompt the user to enter number of rows and columns. Okay, which is enter the size of matrix. Okay. So once the user enters the size of the matrix, which is basically row size and column size, using scanf statement, we can read this row size and column size inside row and column variable. Okay. So which is address of row and address of column, right? So after reading the row size and column size into the variables row and col, so now we can iterate and read the entire elements into the matrix A. So here we'll prompt the user in order to enter percentage D elements. Okay. So how many elements we are basically asking user to enter is clearly row into col. Okay. Because row is representing a row size of the matrix and col is representing column size. Row into column will give you the total number of elements inside the matrix. Okay. So now let's write nested for loop in order to read these elements into the matrix. Okay, so here I'll use j loop as well. J equal to 0, j less than column j plus plus. Okay, so scanf, you can see here percentage d, address of a of I j. Okay, so once you read all the elements into the matrix, now we have to count the number of zero and non-zero elements in this matrix. Okay, so here the main logic starts. Okay, so I'm going to count okay, zero and non-zero elements clearly. Okay, so here you can see for I equal to 0, I less than row in order to iterate each row. Okay, so and again here you can see for j equal to 0, j less than column j plus plus. Okay, in order to iterate column in each row. So now you need to count number of zero and non-zero elements based on this. Okay, so if a of I j, okay, double equal to 0, in that case we need to count z. Okay, else we have to count nz. That's all. If the matrix contains an element called 0, then I'm going to increment the number of zeros, that is z plus plus. Otherwise, I'm incrementing nz plus plus. Number of non-zeros are getting incremented by 1. So finally, we have to print number of zero elements and number of non-zero elements. You can see number of zero elements. Okay, number of zero elements is equal to percentage d slash n. Okay, z. And here also you can see number of non-zero elements. Okay, similarly number of non-zero elements is equal to percentage d slash n, and you can see nz is representing number of non-zero elements, isn't it? So let's execute this particular program, okay, and see the result. So now it is prompting the user to enter size of the matrix. Let's suppose I'm entering 3 by 3 matrix. So I'm prompted to enter 9 elements. So let's suppose 9 elements are 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So you can see number of zero elements are 6, number of non-zero elements are 3 here, isn't it? So this is an identity matrix that I have given as input, which is of size 3 by 3. So number of ones is equal to 3 and remaining all are zeros. Number of zeros is equal to 6. Okay, just like this. So next one is we need to count the number of even and odd elements in a matrix. Okay, so now for this purpose, up to here you can see this is an array and ij are loop variables. Row call represents basically in order to store the row size and column size of the matrix. Okay, so apart from this you can take two other variables like even equal to 0 and odd equal to 0. Okay, so now user has entered size of the matrix and then the elements. So now the real logic begins, isn't it? So that is count number of even and odd elements. Okay, so you can see here, in order to count number of even and odd elements, first iterate the loop, isn't it? Okay, then you can access column wise. Okay, so now even and odd elements in the matrix can be identified by checking whether the element is divisible by 2 or not. Okay, mod 2 double equal to 0. Okay, so a of ij mod 2 double equal to 0, in that case we can say the number is even. Yes or no? The element is basically even when it is divisible by 2. So in that case we can increment the variable called even. Okay, so I'll write even plus plus. In the else case, we can write odd plus plus, isn't it? So after this, once the entire nested for loop is completed, now you can start displaying number of even elements and number of odd elements in the matrix. Okay, so using printf statement, you can write number of even elements in matrix. So you can see here, even is the corresponding variable. Okay, and next similarly, number of odd elements in the matrix. Okay, the number of odd elements in the matrix can be printed by printing odd. Okay, so just like this. Now let's execute this particular code and see the result. Enter the size of the matrix. For example, I'm entering 3 by 3 matrix. The number of elements are 9 elements that you need to enter. So let us suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the number of even elements in the matrix are 4. Okay, so you can see 2, 4, 6, 8. These are even elements, and number of odd elements in the matrix are 5. 1, 3, 5, 7, 9. Like this. Okay. Next program is we need to check whether two matrices are same or not. Okay, check whether two given matrices are same or not. Okay, so in order to check whether two given matrices are same or not, so first of all consider any two matrices. For example, I'm considering both as 3 by 3 matrices. So this is matrix 1. Okay, so I can consider this as matrix 1, and now I'll consider another matrix 2, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you can see here clearly this is matrix M1 and this is matrix M2. So these two given matrices are same or not. First of all, in order to check whether two given matrices are same or not, so two matrices M1 and M2 are said to be same if and only if all the elements in matrices are same. Okay, there should be appearing on the same position as well. Like first of all, order of the matrices must be same. Okay, next one is each and every element in the entire 2D array or in the entire matrix should be same. So here you can see 4, here it is 4. So the same element should be appearing here and there. Okay, so it's basically 5, and here also 5. This is 6 here, and this is 6. So like this, all the elements in the third row, you can see 7, 8, 9. Here also 7, 8, 9. Okay. So whenever all the elements in both the matrices are same, we can say both the matrices are same. Okay. So for this purpose, first of all, I'll explain the logic here and then implement the code directly. Okay. So the logic is, we'll write the nested for loop for this particular program. For example, I'll use for I equal to 0, I less than 3, I plus plus, because I'm considering for these matrices there are 3 rows, and even for the columns we are considering j equal to 0, j less than 3, j plus plus. Okay. So whenever both the matrices are same, okay, what happens is I'll consider A of ij. Let us suppose I'll consider this matrix as A and this matrix as B. Okay. So A of ij, whenever it is not equal to B of ij, okay, the order of the matrices must be same, and I represents the row, j is representing the column. So whenever they both are not equal, in that case we can modify the flag value. Initially you take a flag variable whose value is 0. Now you modify the flag value to 1. Okay. So once you modify the flag value, then you can break this particular loop. Okay. So due to which what happens is, the moment flag value is modified from 0 to 1, it means at least one element is not matching. Okay. So then we can say both the given matrices are not equal. Suppose if you consider this type of example where both the matrices are same, in that case you can see this particular condition is going to produce always false, and this statement will never be executed. So when this statement is not getting executed, value of flag will be 0 forever. So when value of flag is 0, we can say both the matrices are equal. Okay, like this. So let's implement code for this. So this is the initial code. I'm considering main function here. Now we need to consider two matrices. Let us suppose first matrix is A and second matrix is B. Okay. Also, we need to consider I, J as loop variables, and em row and column. Okay, row, column. So both are representing row size and column size respectively. Now we'll also consider flag variable whose value is initially 0. Okay. So now we will modify the value of the flag at the end. Okay, as explained in the logic. So first of all, we must focus on reading the array A and reading the contents into array B. Okay. So basically there are matrices, right? Matrix A and matrix B, 2D arrays. Okay. So first we will prompt the user to enter the order of matrix, order of matrices. As I told, for this problem we require both the order of matrices should be same. Okay. And using scanf statement, you can read the order in a variables called row and call. So this should be address of row comma address of call. Okay. So after reading the row size and column size into this variables row call, now let's ask the user to enter percentage d elements. Okay, enter percentage d elements in matrix A. Okay, or you can say matrix A like this. So once the user enters elements into matrix A, okay, so how many elements the user is allowed to enter is equal to row into column. Okay, so once the user enters those many elements into matrix A, okay, using for loop you can read, okay, I equal to 0, I less than row, I plus plus. Okay, again for column also you can see for j equal to 0, j less than col, j plus plus. Okay, now we can read the entire content into the matrix like percentage d comma address of a of I j. Okay, so similarly we have to read matrix B also. I'll just copy paste the same content, but instead of matrix A it should be matrix B. Okay, and here also it should be matrix B. So once the content is read into matrix A and matrix B, now we have to check whether both these matrices are same or not. Okay, so in order to check both the matrices are same or not, again we have to make use of nested for loop and iterate. Okay, so for this purpose, remember this is the main logic, which is checking equality of two matrices of two matrices. Okay, now for I equal to 0, I less than row, I plus plus. Okay, for j equal to 0, j less than col, j plus plus. Okay, now inside this nested for loop you can see a of ij not equal to b of ij. Okay, whenever a of ij is not equal to b of ij, in that case immediately modify flag value to 1. Okay, so either you can make use of break statement or not. Okay, but still it break statement just helps to reduce the number of iterations, so it's not a big deal. Now once the entire execution of this loop is over and flag value is modified, in that case we can say based on the value of the flag, isn't it? When flag value is 1, immediately we can say printf two given matrices are not equal. Okay, this is one case. Okay, and the other one is similarly else block. In the else you can write printf two given matrices are equal. Okay, like this. So let's execute this particular code and see how this is going to work. Okay, So enter the order of the matrices. I have entered 3 by 3. Now it is asking us to enter 9 elements in matrix A. So let's suppose I'm entering elements like 1, 2, 3, 4, 5, 6, 7, 8, 9. Enter 9 elements in matrix B. 1, 2, 3, 4, 5, 6, 7, 8, 9. Since I have given the same elements, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. Both the matrices elements are same. Hence it is producing two given matrices are equal. Okay, like this. So let's execute one more time and give a different input. Order of the matrices are 3 by 3. Enter 9 elements in matrix A. So you can see 1, 2, 3, this time 4, 5, 6, 7, 8, 9. Now I'll give some other matrix like 9, 8, 7, 6, 5, 4, 3, 2, 1. So you can see the elements are basically different in both the matrices, hence it is going to display two given matrices are not equal. Okay, like this. So coming to the next one, here we need to basically check whether given matrix is identity matrix or not. Check matrix is identity matrix or not. So how you can check whether the matrix is identity matrix or not? For example, if you consider 3 by 3 matrix, which is an identity matrix, it looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. This is called identity matrix. So from this matrix, you can understand in identity matrices, the diagonal elements are always 1, no matter what is the order of the matrix. So first thing you have to understand, diagonal elements are 1. Okay. So another thing is all the non-diagonal elements are simply 0. So we can write non-diagonal elements are zeros. Okay. So how we can write logic when you are checking, for example, of course you have to iterate here. I equal to 0, I less than 3i plus plus for this particular matrix. And again, for j equal to 0, j less than 3j plus plus. Okay. And always remember, whenever I and j are equal, that is representing the diagonal elements, isn't it? So in the diagonal elements, it should be always 1. If I and j are equal, it means I double equal to j, logical end. Okay. So you can see here, I'll make use of count variable. Okay. So count equal to 0 initial, I double equal to j, and also you can see here a of ij double equal to 1. If both the conditions are met, okay, you can simply increment the value of the count, isn't it? So I'll update count value. And similarly, you can also write another condition, that is I not equal to j for non-diagonal elements, logical end. A of ij should be 0. Okay. So even in that case, you can increment the count value, count plus plus. Okay. So when this count value is updated completely, okay, it is going to be an identity matrix if and only if this count value is equal to the number of elements inside the matrix, number of elements in the identity matrix. So here the 3 by 3 matrix number of elements are 9, so 9 here, or this can be written as row into column. Okay, so if this is the case, we can simply print, okay, clearly the matrix is identity matrix. If this is the case, we can write identity matrix. Okay, suppose if this is not the case, then in the else we can write printf not an identity matrix, not an identity matrix. Okay, like this. So this is a fundamental logic in order to implement this. Okay, so let's start implementing the code level. So here also we should make use of arrays. Okay, that is a two-dimensional array. So you can see here clearly. First, I'll take an integer array A, okay, of size 10 by 10, and also I is a loop variable and j is a loop variable. Now we have to consider also the row size and column size for the matrix. Okay, and also count variable. Initial value of count is 0. Okay, so here again first prompt the user to enter order of the matrix. Okay, so once the user enters the order of the matrix, now you can make use of reading those row size and column size, isn't it? So address of row comma address of col. Now we have to prompt the user to enter those many elements, row into column, right? Enter %d elements. So once the user started entering, that is row into col. Okay, so using nested for loop, we can write I equal to 0, I less than row I plus plus. Okay, again for j equal to 0, j less than col, j plus plus. Okay, so here you can make use of scanf statement in order to read this entire array. %d address of a of I j. Okay, so once the matrix is taken from runtime, just like this, now here we have to write the logic in order to check whether the matrix is identity matrix or not. Okay, identity matrix or not. Okay, so first let's write the outer for loop I less than row I plus plus. Okay, now we can write inner for loop here just like this. So here we can write the condition just like this. The first condition is I double equal to j logical end. Okay, a of I j. Okay, it means we are basically referring to the diagonal elements. Right, so no, so double equal to 1. In that case, I'll increment the count. Okay, So very simple. This condition is for diagonal elements. Okay, diagonal elements in matrix. So similarly, we can write one more condition for all non-diagonal elements. Okay, so I not equal to j logical and a of I j double equal to 0, because all the non-diagonal elements in such matrix, which is identity matrix, will be 0. Okay, so here also I'm incrementing count plus plus. Okay, so either way you can see for identity matrices the count will be incremented. Okay, and either it can be, you know, this condition becoming true or this, but not both. Okay, because this is a condition for all diagonal elements. Okay, and I'm referring to the next condition. So this is for all the non-diagonal elements. Okay, non-diagonal elements in the matrix. So after performing this, now you can check the count variable is equal to row into column or not. Okay, if the count double equal to row into column, in that case we can print given matrix is identity matrix. Okay, simply identity matrix. Okay, so if this is not the case, it means in the else we can write not an identity matrix, not an identity matrix. Okay, like this. So this count is exactly representing the number of elements which are in the form of identity matrix format. Okay, so once all the elements are in the format as per the identity matrix format, where the diagonal elements are ones and all the non-diagonal elements are zeros, then count is equal to the total number of elements in the entire matrix, which is nothing but row into column. Okay, so let's execute this particular code and see the result. Okay, enter the order of the matrix. Here we are entering order of the matrix as 3 by 3. Now I am entering the 9 elements in the matrix. Let us suppose 1 0 0 0 1 0 0 0 1. This is exactly the identity matrix, right? So it is able to produce a result as identity matrix. For example, now I'll run for another matrix like order of 3 by 3. This time I'll give the different elements like 1 2 3 4 5 6 7 8 9, and this is purely not an identity matrix. Okay, like this is going to work. Okay, so now we will implement addition of two matrices program. Okay, so let's see how we can implement this addition of two matrices. Okay, so first for this purpose let me take two matrices here. Okay, so consider A is one matrix and B is another matrix. And also, after performing addition operation, the result must be kept inside a matrix C. Okay, so I comma j to iterate through rows and columns respectively. And also we need to take row size and column size as well. Okay, so now first we will prompt the user to enter order of matrices. Okay, So once the user enters the order of the matrices, like you can see %d, address of row, comma, address of column. Okay. So now, in order to iterate through this matrix A and store all the elements into matrix A, so quickly we'll ask the user to enter elements into matrix A. Enter elements into matrix A. Okay. So whatever elements that user is entering into matrix A, okay. So we have to read those elements, right? So how many elements? First, give a hint here. So enter %d elements, which is nothing but row into column. Okay. Now we'll read those elements into matrix A. I equal to 0, I less than n, I plus plus. So here basically we are looking at row size. Okay. And similarly for j equal to 0, j less than column. Okay. And j plus plus. Okay. Now we can take the element first into array A here, %d, address of A of I, j. Okay. So once the elements are entered into matrix A, now similarly, quickly you can enter elements into matrix B as well. Okay. Just modify this here, matrix B, and here also matrix B. Okay. Because for addition operation, always remember the size or the order of the matrices should be same. So this program is clearly related to matrix addition. Okay. So after reading matrix A and B, now we have to calculate to perform matrix addition. Okay. Matrix addition operation. Now using nested for loop, you can read. Okay. So I less than row I plus plus. Okay. And here again for j equal to 0, j less than column, j plus plus. Okay. So how we can perform matrix addition? It's very simple. We have already taken matrix C in order to store the result, isn't it? So C of ij is equal to A of ij plus B of ij. Okay. So once the entire matrix addition is performed, now the result is clearly stored inside the matrix C of ij. Okay. So once the result is stored in C of ij, now we can display the matrix. Okay. Here I can write displaying a resultant matrix. So how can I display resultant matrix? So simply again I equal to 0, I less than row, I plus plus. Okay. And similarly write the j loop, j equal to 0, j less than col, j plus plus. Okay. Here we can print element by element here. Okay. %d slash t. A of, like, result is stored in a matrix called C, right? So C of ij. And after printing the element, now after printing the entire row clearly, okay, now we need to display the element in the next line. Yes or no? Displaying the resultant matrix. Clear? Just like this. So Now we will execute the entire program here. Okay. So enter order of matrices upon which we are basically performing matrix addition. So consider 3 by 3 matrix order. So enter 9 elements into the matrix. For example, simply I'm entering 1, 1, 1, all ones, let us suppose. Yeah. So now another 9 elements into matrix B. So let me enter all 2s for this particular matrix. Okay. So now you can see the result. The result is clearly 3, 3, 3. Okay, like this. This is matrix C corresponding result. Okay. So this is how we can perform addition between two matrices. So let us suppose you want to display clearly printf displaying matrix C, for example, displaying matrix C, or we can say displaying resultant matrix. Clear? Anything. So obviously that statement will be printed and then the result will be printed. Okay. So now if you want to perform matrix subtraction operation between two matrices. Okay. Subtraction between two matrices. Okay. So how this subtraction can be performed between the matrices, you can see here clearly. So instead of plus, if I use minus, okay, so the rest of the code will be similar. Clear? Everything is same, just instead of performing addition, you need to perform subtraction over matrices. So let's execute this code. Enter the order of matrices. 3, 3 is the order. Now I'm entering all the 9 elements into matrix A. For example, all the elements in matrix A are 9, 9, 9, 9, 9, 9, like this. Okay. So now they're asking 9 elements into matrix B. Okay. So let us suppose I am entering all 5s in this particular matrix. Okay. Now you can see the result displaying matrix C. All 4s you will get because 9 minus 5 is 4, right? So every element is computed as 4, 4, 4, 4 like this. Okay. So from this point, how we can perform matrix multiplication. Okay. So again, in matrix multiplication, so the concept is different because you can't simply put multiplication operation here. You cannot put. So because in addition and subtraction, the respective elements are taken in the matrix for performing addition operation, for performing subtraction operation. So but here clearly in multiplication, we consider a row and the column elements are getting multiplied and the results are added, right? So matrix multiplication will be different. Okay. So let's implement matrix multiplication code. For simplicity, I'm considering here a compile time initialization for both the matrices. Okay. So consider the compile time initialization of the matrices like A of 3, 3, for example. So here all the elements 3 by 3, 9 elements I'm considering like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay. So this is matrix A. And now matrix B, okay, is equal to, let us suppose I'll consider matrix B as all elements 1, okay. So you can see clearly the number of rows and number of columns are 3 and 3. And also here we'll take C of 3, 3, another matrix C here. And also we'll take loop variables I, J, K clearly. Okay. So now using for loop, you can see here for I equal to 0, I less than 3, I plus plus, in order to perform matrix multiplication. So I'm writing directly the logic here. Okay. Matrix multiplication corresponding logic. Okay. So here again, write down J loop, J equal to 0, J less than 3, J plus plus. Okay. So here initially we'll consider Cij equal to 0. Okay. Now we need to consider K loop. For K equal to 0, K less than 3, K plus plus. Okay. So the formula for matrix multiplication is Cij is equal to, okay, again we need to add Cij here. So or we can write simply using this operator, plus equal to Aik into Bkj. So this will be Aik multiplied with Bkj. Okay. So after performing this multiplication, the result is stored inside the matrix C. Okay. So after storing the entire result in matrix C, now you can display the results of matrix C. Okay. Displaying matrix C here. So how you can display matrix C? Again, we have to make use of this nested for loop. Okay. And here we can display Cij elements, percentage D slash T, again Cij. Okay. So after printing this particular element, now you can print slash n. Okay. It can go to the new line. Okay. So before printing the entire matrix C, just write down a printf message saying displaying matrix C. Okay. So we can write printf resultant matrix. Resultant matrix is okay slash n, like this. So let's execute this particular program and see the result. Okay. So now you can observe clearly resultant matrix is 1, 1, 1, 1, 1, 1. So always remember, if you multiply an identity matrix with matrix B, you will get matrix B only. Okay. So identity matrix into matrix X will give you the result as X. Okay. Whatever you are multiplying, that will be the result if you are considering identity matrix. Okay. So this is how it is going to produce a result. Okay. So for simplicity, I have taken compile time initialization, because we have been doing runtime initialization from long time, isn't it?
So next one is three-dimensional arrays, which is an example for multi-dimensional array. So in case of multi-dimensional array, we have multiple dimensions, like if you consider three-dimensional array, same example. So first one is table size, second one is row size, third one is column size. So let's see this particular example here. 3D array, three-dimensional array. Okay. So according to this three-dimensional array, you can see here the general syntax of this three-dimensional array will have totally three dimensions. Okay. So you can observe here data type, okay, space array name. Okay. And in this array, we are going to consider three dimensions because this is an example for 3D array. Okay. So the first dimension is representing the table size clearly. Table size is the first dimension. Second dimension is row size. And the third dimension is column size. Okay. Just like this. So table size, row size, and column size. These are the three dimensions. And the number of elements that can be stored inside this three-dimensional array is equal to table size into row size into column size. Okay. So you can write here number of elements that can be stored. Okay. That can be stored is equal to, so table size into row size into column size. Okay. So this will give you the total number of elements that can be stored inside the 3D array. Okay. So now we'll see how we can initialize a 3D array. Okay. So initialization of 3D array. In this 3D array initialization, we can write like this: data type, okay, array name. So here you can write the table size, okay, and then you can write the row size followed by column size, okay, is equal to list of values. We have to mention the list of values here and followed by semicolon. Okay. So the list of values can be specified either row wise initializer list you can write or table wise initializer list. Okay. Suppose you want to create two tables, then write down all the elements which are related to table 1 in the first initializer list and table 2 in the second initializer list. So we will consider an example here clearly. Example is int a of 2, 2, and this is also 2. So how many elements are there here clearly? So there are two tables, first of all, two tables, and in each table how many elements are there? 4 elements. 2 into 2 which equal to 4. Okay. So you can observe here two tables, that is 1 2 3 4, okay, 5 6 7 8. Clear? Like this. So in the first table the elements stored are 1 2 3 4, and the second table the elements stored are 5 6 7 8. Okay. So you can observe here clearly there are two tables. Okay. and in each table there are 2 rows and 2 columns. Okay, so if you consider this is A, okay, and this is going to be 0th table and this is going to be the first table, okay, because table size is given as 2, 0, 1, okay, and you can see row size and column size 2, 2, right? So these are given like this 0, 1, 0, 1, and this is 0, 1, 0, 1, okay. So the elements that are mentioned in the first row are 1, 2, 3, 4, okay. So 1, 2, 3, 4. And the elements that are mentioned in the second row are 5, 6, 7, 8. Okay. So the first table contains 1, 2, 3, 4, and the second table contains 5, 6, 7, 8 elements. Isn't it? Just like this. Okay. So now you can actually read these values into three-dimensional array at runtime, and also you can display these values in the screen. For example, I'll show you an example for displaying these 3D array elements. Okay, so let's consider like this. First, include the respective header file. Okay, and now inside the main function, first consider an array. Okay, which is a three-dimensional array, A of, let us suppose 2, okay, 2, 2, okay. And what are the elements here? There are 2 initializer lists, 1, 2, 3, 4, and the next list is 5, 6, 7, 8, okay. So now we are iterating this particular 3D array and we need to display the elements clearly, okay. So int ijk, okay. So I is a loop variable which is representing the outermost loop. J is a loop variable indicating the middle loop, and K is a loop variable indicating the innermost loop. So we are using this outermost loop to iterate the table and the middle loop to iterate the row in a table, and the innermost loop is used to iterate the column elements in the row of the table one. Okay, so just like this. So let's access and display this particular 3D array, three-dimensional array. I equal to 0, I less than 2, I plus plus. Okay. So now using the J loop, you can see J equal to 0, J less than 2, J plus plus. Okay. Next, using K loop here, for K is equal to 0, K less than 2, K plus plus. Okay. So you need to print this particular elements like this. Printf %d. Here A of ijk, using A of ijk, you can access this particular array of elements and display here. Okay. So, and you want to access using row wise, right? Once all the column elements in a row are printed, then use /n. This will move to the new line, isn't it? And then, okay. So here you can write printf another /n/n, okay, like this. So this is the innermost for loop, and then this is the middle loop, and this is the outermost for loop, isn't it? So using which you can actually iterate and display the elements in the both the tables, because here table size is 2, okay, row size is 2, and even the column size is 2. So the number of elements that can be stored inside this particular three-dimensional array is 2 into 2 into 2, which is nothing but total 8 elements. So let's see how this is going to be created here. Writing this particular 3D array represents, this is going to be table 0, okay. So in the table 0 you have a total of 4 elements, yes or no? So 0 1, and this is also 0 1, okay. So the elements stored are 1 2 3 4, okay. Next, similarly, next one is table 1 here, okay. Table 1 containing elements 5 6 7 8, okay, like this. So 0 1 0 1 5 6 7 8, okay. So in this, now how you can access and display the elements is that, so in the first iteration, a of I j k, okay, I equal to 0, j equal to 0, and k equal to 0, a of 0 0 0, okay, which means 0 0 0, this particular element will be displayed first, okay. So in the next iteration you can see k plus plus, k value will be incremented by 1 and k value becomes 1, 1 less than 2 condition becomes true. So since this condition is true, now it is going to display a of 0 0 1, a of 0 0 1 is 2, okay. Next, you can see k value is becoming 2, 2 less than 2 condition false. In the outer for loop, j value will be incremented by 1 and j value becomes this time 1, 1 less than 2 condition becomes true. So now k is going to iterate for 0 and 1. It means we are referring to this particular row, and these elements will be displayed clearly. 3 and 4 will be displayed, okay. So once j value becomes 2, 2 less than 2 condition false, it will move to the outermost for loop. I value becomes 1, 1 less than 2 condition becomes true. Now it will enter for the inner for loop, and j value will be still 0, k value will be 0, 0 less than 2 condition true. So this time it is going to print this element, okay. Then k value becomes 1, so prints this element. Next, k corresponding 2 less than 2 condition becomes false, it will go for the j loop and it is going to print these two elements also, okay, like this. So you can see after printing this particular table 1, it is going to print table 2 elements 5 6 7 8, just like this, okay.